Okay, illustrative math, Algebra 2, Unit 4, Lesson 6 is called Writing Equations for Exponential Functions. All right, so our goal today is I can write equations for exponential functions from two input pairs, even when the input pairs are not 1 unit apart. Okay, it's up until now we've mainly been sticking with, points that are 1 unit apart. Usually they give you the initial value when x is 0, and then they give you the value when x is 1. So we're going to make it a little bit harder. It's important to remember that an exponential function is y equals a times b to the x. Okay, so a is your initial value, b is your growth factor. X and y are really the coordinates of any point on the graph that you could plug in. There's obviously, if your graph is, growing, there's obviously multiple x and y points that you could plug in there to keep this equation balanced with the left side equal to the right side. So, all right, so warm up. Discuss with the partner why the following expressions are equivalent. Okay, so 64 to the 1/3. Well, that just means 64 cubed root, and that's going to equal 4. Why is that equal to 4? Because cubed root means what number times itself 3 times gives us that value of 64. All right, so here this is going to equal 8 to the 2/3. You multiply your powers. 2 times 1/3 is, put that over 1, 2/3. So then this means the bottom number is your root, the top number is your power when you have a fraction exponent. So again, I'm doing all this without a calculator. You want to try to do these without a calculator. So cubed root of 8 is 2. Again, it's kind of like the 4. It's 2 times 2 times 2 equals 8. So this is really like saying 2 squared. So that whole thing is 4 as well. All right, multiply your powers. 3 times 2/3. These cancel, so I just get 2 to the second, so that's 4. Multiply your powers here. I'm going to get 8 to the 2/3 again, which I already did all that, so I know that's going to equal 4. And then we already did that as well, so that's going to equal 4. Okay? What's another expression equivalent to these? I got to equal 4. So how about square root of 16, which would be 16 to the 1/2? That would work. Okay. All right, so quick little review. If I were to solve x squared equals 9, you square root both sides. We get x equals positive and negative 9. Now, what's a different way we could solve x squared equals 9? So you want to think in terms of exponents. So remember, square root is the same as 1/2 power, right? Because if I said, what's the square root of 9? That's the same as saying 9 to the 1/2, right? They're both going to give you 3. So couldn't I, instead of square rooting both sides, couldn't I take each side of the 1/2? If you multiply 2 times 1/2, it equals 1. So this is just x to the 1 is equal to 9 to the 1/2, which we know is 3. Okay? And technically, you would also need your plus and minus there. All right, so solve this 2 different ways. So, I'm going to cube root. Don't need a plus or minus if your root is odd. So it's just x equals 3. The other way I'm going to do it is I'm going to take it to the 1/3 power, because that's the same as a cube root. So these, you multiply them, you just get x to the 1, which is x, and then 27 to the 1/3 would be 3. Okay, so 2 different ways. So what do you notice about the power you raise an exponent to? So that is always going to be the reciprocal. Okay, so, you just flip it. So example here, if I had x, If I had x to the 2/3, you can just raise it to the 3/2. And that would, the 3's would cancel and the 2's would cancel when you multiply, so that would give me x. Okay? Oh, I'm a step ahead. So same idea here. 3/2, 3/2. So 2/3 times 3/2 is just 1. And then it's going to be 8 to the 3/2. Now this one I can't simplify because it's going to be like square root of 8 to the 3rd power. 8's not a perfect square. So you can just leave it like this. You could type it in as, or you could write it as square root of 8 cubed. Or if you wanted to get a decimal, you could just type in 8 to the 3/2 and you get 22.63. Obviously, these are better because they're exact. This I had to round. This would go to the reciprocal 5/2 because when I multiply these, I get 1. And that's what I want. So this would be x. Okay, and if you're still having trouble with that, remember 2/5 times 5/2. When I multiply by the reciprocal, I get 1's here. These become 1's. The whole thing's 1. So 4 to the 5/2. This one I can do. I can square root the 4 and then take it to the 5th. So square root of 4 is 2. 2 to the 5th would be 32. Okay. All right. So a little review here. Exponential functions. Kind of already talked about that on the goal slide. Remember, it's y equals a times b to the x. A is your initial value, which is always your y-intercept. B is your growth or decay factor, so it's 1 plus or minus r. R is your growth rate or your decay rate. All right, so a quick little review here. Write an exponential function that starts at 3,500 and grows exponentially, increasing by a rate of 4.2% each year. So A is 3,500. It's times 1.042 to the x power. And there's my function. X is years. And f of x, we didn't really say what it was, but f of x equals whatever. It could be population, bacteria, whatever. I didn't put it in there, but there it is. All right, so now same idea. This time it's just a graph. Okay, so same thing here. So this is my initial value because that's at 0. So a equals 700. So b, so this is at 1. So what we've been doing is we've been saying, oh, okay, 700 times what gets me to 952? And since it's 1 unit away, we could say, 700 times what number gets me to 952? And we've been dividing by 700. And we're saying, oh, okay, well, really, maybe B would be better than X. Hang on, let me rewrite that. So when I divide by 700, I get my growth factor. B is 952 divided by 700. I get 1.36. So now I can say, okay, 1.36 to the x equals y. And then it says write the function f. So maybe I'll write it as f of x instead of y. So there's my function. All right. Now, what we're going to do is, if this value is not 1, it's a little bit harder here. So what I'm going to do is this. I'm going to show you a different way here. I still have this y equals a times b to the x. A is 700. We don't know what b is, but since we know this point here, I'm going to plug in the 1 for x, the 952 for y. Okay, so now that allows me to have enough info here to find b, because I've gotten rid of 3 out of the 4 variables. So it ends up being the same thing that we did. We get the 1.36 equals b. But now, if this number was like 1/2, I could now square both sides to get rid of the 1/2. Or if this number was like, 3/2, I could raise each side to the reciprocal, okay? All right, so here's a problem where we have points that are not on the graph, okay? So they want you to do this info gap thing. I just put both cards here. So we want to find an equation defining f. So here's my graph of f. So my y-intercept is 200. So that's helpful. Y equals a times b to the x. So a is 200. They don't tell me my growth rate for a unit of 1. From 0 to 1.5, it's like it's not a whole number multiple of 1. So this isn't going to work. So what I'm going to do is I'm going to leave b as my variable. And since I know these points here, I know b and I know c, you could use either one of them. B is, 0.5, 300, or you could use c. C is 1012.5. That's the y coordinate. The x coordinate is 2. Okay, either one of these, you could plug these in for x and y right here, and that'll give us enough info to find b. So I'm going to use this point here. I'm going to plug in the 2 for x, because that's an x coordinate. I'm going to plug in the 1012.5 for y, and now I got to solve and find b. So I'm going to divide by 200 first. So that gets me here 5.0625, and then I square root both sides, and I get b equals 2.25. Okay, so that's useful. Now I know a, I know b, I have my function. So instead of y, I'll call it f of x. Initial value was 200 times 2.25 to the x. Okay. All right, here's another one. So my y-intercept is 100. So 0, 100. B is 50, so b is 1/4 50. C is 3/4 12.5. So, and then they give you this rate of decrease. I'm going to just stick with the way I did it before. Y equals a times b to the x. I know a is 100 because that's my initial value. I'm going to find b, and I'm going to plug in, I'm going to use this point here. I'm going to say b to the 1/4. I'm going to plug that in for x and plug in the 50 for y. So I divide by 100, divide by 100, and then I'm going to raise this to the 4th because I want that to equal 1. So I get b equals 1/2 to the 4th. I could take 1 to the 4th and get 1. I could take 2 to the 4th and get 16. That way I don't have to round. So there's my b. So my function is, and it says to use g. So instead of y, I call it g of x equals 100 times 1/16 to the x. Okay. And I could have used this point here. I would have raised it to the 4/3. It would have worked the same exact way. All right. A bacteria population starts at 1,000 and doubles every 10 hours. Okay, so, 1,000 is at 0, double at 10 hours, double at 20 hours, doubles at 30 hours, and so forth. Okay, so every hour would be 1/10 of a doubling time frame. So if it takes 10 hours to double, 1 hour would be 1/10. So 1,000 is their initial value. Your rate of change is 2, but it's every 1/10 of an hour. So it'd be, if I multiplied those, it would give me the exact same thing here. So it'd be, sorry about that, h over 10. Okay, so basically 1,000 is your initial value, 2 is your rate of change, and then if I multiply these power to power, it'd be 1/10 h, which is the same as saying h over 10, because really it's 1/10 times h over 1. If I multiply that out, I get h over 10. So these are identical. So every 1 hour, by what factor? So what are you multiplying by? So I'm multiplying by 2 to the, I'm plugging in 1 for h, 1 hour, 2 to the 1/10. Okay. And how do I know I plug 1 in for h? All right, so here's another one here. Population doubles every 8 hours. Find the population in 20 hours when it starts at 1,000. So I'll use P for population. 1,000 is your initial value. You're timesing it by 2, but it's every 8 hours. So it's your total hours divided by 8. Because think about it, if you in 8 hours, if I plugged in 8 for h, it'd be 8 over 8 would be 1. So let's just kind of imagine here, say I plugged in 8 here. 8 over 8 is 1. So it'd be 2,000 after 8 hours. So, and you kind of figure it out here. 1,000 at 0, you'd have 2,000 at 8. Okay, so that makes sense there. So 20, I just plug in 20. Let me erase all this. So 20 over 8 is, with that, 5 halves. So 1,000 times 2 to the 5 halves. And I'm going to type that in my calculator because I can't do that in my head because I can't square root the 2. 2 is not a perfect square. So I end up getting 56.8. So I'm not going to have 0.8 of a person, so I'm going to just round it up. Doesn't really tell me how to round. So there it is. All right. So here's my graph. Where on a graph do we see the initial value A? So that would be right there. So I would say 0, 300. What do we know about the function when x equals 1.5? We would say that the y coordinate is 153.6. Can we use 300 equals b to the 1.5? Yes, because basically you took your function, we plugged in the 300 for a, we plugged in the 1.5 for x, and we plugged in the 153.6 for y, and that's how we got this equation here. So I would probably divide each side by 300. So I'm going to come over here, b to the 1.5 equals, I'm going to get a decimal, 153.6 divided by 300 gives me 0.512. And then, what do I raise this to? Well, you could do 1 over 1.5, or maybe just convert that to a fraction, make it 3 halves, and then I could raise everything to the 2/3. Okay, these cancel out because they're reciprocal. So 0.1 or 0.512 to the 2/3 gives me 0.64. So now that I got B, my equation doesn't say to use F or G, so I'll just use Y. Y equals 300 times 0.64 to the X. All right, so our goal, I can write equations for exponential functions from two input-output pairs, even when the input pairs are not 1 unit apart. All right, last slide here. So here's a graph representing the function f of x equals a times b to the x. Find the values of a and b. So obviously this is a. That's my initial value. So I'll use y. Y equals 8 times b to the x. So then I'm going to use this point here. This is my a, and I plug this in for x and y. So 18 equals 8 times b to the second. So you got to divide first. So this gives me, what is that, 9 over 4 if I reduce it. That's kind of nice because I could square root both sides, or I could take it to the 1/2. I'm just going to square root. So now it's nice because I can, these are both perfect squares. 3 over 2 equals b. So now my equation is f of x equals initial value a times b to the x. There we go. All right, so thank you for watching the video. Hope you enjoyed it, and we'll see you next time.